Good morning, physics seniors. This is day 5 of week 5. This is the third and final video of the fifth week. We have 7 weeks of instruction, so after this video and the work that's due on Sunday night, you have 2 weeks to go. We are 71% of the way, so congratulations. This is all going to make some sense. I hope soon you'll know more about your graduation ceremony plans. I certainly regret we're not going to be able to share prom with you, etc., but let's do our best to keep this moving. I did want to send a note out to you, a message. If you do need some help with reference letters for summer jobs, reference letters for scholarships, etc., please contact me. Again, tbennett@osceola.org, or the hotmail is tbennett62@hotmail.com. And certainly if you need forms filled out, or sometimes preferential housing, etc., sometimes they're freshman honors dorms, we're excited for you. This is a crazy time, we know, but I hope you'll make the best of it, and let's get you loaded up. For my military friends, certainly think about taking that ASVAB again if it's possible. Get those scores up and get those numbers, because I'd much rather see you being evaluated for the nuclear program or being sent through the Army, Navy, Air Force medical program versus peeling potatoes down in the kitchen. So let me know if we can help you with those references at all. Okay, this is the work again due for Sunday night, May 3rd. There are 6 key terms found on page 713. There are 6 think questions scattered throughout chapter 35, and there are 6 concept check questions. This means at the end of each of the sections, you will find a convenient little concept check question. The big part of the work is answers questions 1 through 30 of chapter 35 assessment, and explain a little bit about how the grades work. Please recognize that there are a lot of grades in the very first unit. There were 5 grades off the packet. There were 2 grades off the definitions and 3 off the chapters. So that consumed quite a bit of time on the first 2 weeks, and those numbers represented there. But again, by Friday, May 1st, there are 16 items in there. Probably bank on about 2 items, and then there's a writing assignment. Probably about 19 total grades will come out of this. Again, we're only required to have 7, but I thought 19 would give you an opportunity to certainly work across the means and see what is happening there. Okay. One of the questions we talk about is overload, and we have sections 6 and 7 to cover today in the concept summary to wrap up week 5. I like part of what the author tells us here. It says that there are concerns about having too many appliances operating a system, and why different sets of lines are directed to various parts of the home. Most of your wiring in the house is rated at a 30 ampere maximum. Okay, and air conditioner will run about 2400 watts. So if operating on 120 volts, the current should be about 20. You put the 2400 over the 120, and that value is 20. Okay. To start, the current is more. If other devices are drawing current on the same line, the fuse will blow and the air conditioner is turned on. So 220-volt line is usually used for such heavy appliances, okay, versus the 110s. Point out that the household voltage in most of the world is 220 to 240 volts. So we mentioned this before too. When you travel with, sometimes you may try to shave in the airplane, your hotels, your inns, if you're traveling in Europe and Asia, you just have to be very careful with the devices you bring from America, because they're not always going to be conveniently set up when you go into those other countries. It will certainly make your other hotel visitors real happy when the whole wing is going to be blown out. Okay. If you also talk about the resistance in the film of a light bulb varies with the temperature. When cold, at about room temperature, 68 degrees Fahrenheit or so, it may be only 16 ohms in a 120 volt, 60 watt bulb, while 100 ms later, when it reaches its operating temperature, filament resistance increases to a steady 240. So it may take them a while to average out and pull that in there. Okay, you had a question on the end of 6 that said, what's the equivalent resistance of resistors in series of equal resistors in parallel? Okay, so the equivalent resistance of resistors in series, in this one it says documented in series is the sum of their values, What happens if the equal resistors in parallel? The equivalent resistance for a pair of equal resistors is parallel is half the value of either resistor. Okay, so please understand that when you have them in parallel, you do divide the load, and that certainly prevents us from having to use devices like the fuse box. Okay, the lead wires are called lines that enter into the house. Okay, they're very low in resistance and are connected to wall outlets in each room. About 110 to 120 volts are impressed on these lines by the power company. This voltage is applied to appliances and other devices that are connected in parallel by plugs to these lines. As more devices are connected to the lines, more pathways are provided for current. So pretty much you divide it. You have an incoming source and you divide it and spread it out. What effect the additional pathways produce? The answer is a lowering of the combined resistance of the circuit. A greater amount of current occurs in the lines. Lines that carry more than a safe amount of current are said to be overloaded. The resulting heat may be sufficient to melt the insulation and start a fire. So on top of looking at the fact that the wires can become ignited, we also get into the fuse breakers and the circuit breakers. Okay, basically fuses or circuit breakers are connected in series along the supply line, and this way the entire line current must pass through the fuse. The safety fuse shown on page 712 will hit at about 20 amperes, but no more. So anything above 20, you will have the small amount of soldered wire there that will begin to melt, and that's going to shut this down, which is a very convenient measure to save your property and save the rest of your house. Okay, there are about 7 bullet marks in the chapter. I'm going to walk through a couple of those with you. To prevent overloading, fuses or circuit breakers are connected in series along the supply line. The equivalent resistance of resistors connected in series is the sum of their values. The equivalent resistance for a pair of equal resistors in parallel is half the value of either resistor. In a schematic diagram, resistance is shown by the zigzag line, and ideal resistance-free wires are shown with solid straight lines. In a parallel circuit, each device operates independent of the other devices. A break in any path does not interrupt the flow of charge in the other paths. If one device fails in a series circuit, current in the whole circuit ceases and none of the devices will work. These are your party lights. These are your old-fashioned Christmas lights. For a continuous flow of electrons, there must be a complete circuit with 0 gaps. In a flashlight, when the switch is turned on to complete electric circuit, the mobile conduction electrons already in the wires and the filament begin to drift through the circuit. Okay? And please, again, take some time on the think questions. There are a couple of those that do require some calculation. Okay? I'm going to ask you a couple of questions about batteries later in the chapter. 43 asks you, a battery has internal resistance, so the current it supplies goes up. So if the current it supplies goes up, the voltage it supplies goes down. If too many bulbs are connected in parallel across the battery, will their brightness diminish? Explain. The answer is yes, because of increased internal resistance in the battery, reducing available voltage in circuit. Okay, a number of light bulbs, this is 41, a number of light bulbs are to be connected to a battery. Which will provide more overall brightness? Connect them in series or in parallel? Which will run the battery down faster? The bulbs connected in series or the bulbs connected in parallel? So the first question is overall brightness, and the second one is who's going to run the battery down. Okay, in both cases, it's parallel. So parallel circuitry will give you more of the brightness, but it also will run through and will run down the battery quicker. Okay, if you look at 42, this will require you go into the book, please. In 42, the question says you have ABC, 1, 2, 3, left to right. Are these circuits equivalent to one another? Why or why not? Okay, and the answer is yes, they're equivalent. Each branch is individually connected to the battery. If you notice, the housing and the wiring is such where they have a direct connection down to the red over to the battery source. Okay, this concludes our sets of notes for 35. Please, again, have everything ready on May 3rd for the 5th week. You will have a writing assignment in week 7, which is your finals week. Your senior benefit is you will not have instruction the week leading into graduation. And again, I hope you'll know something soon about the plans. And as you well know, states are opening up, malls are opening in certain areas. We just really need to be safe and careful. I hope you understand that for us as teachers, we certainly regret the fact that the prom didn't happen, the honors night, etc. And I hope you'll agree that we're doing the best we can, taping the ceremonies, taping the awards, the little 5th grade, 8th grade promotions. Lots of things happen on our campus. But again, I also believe that to whom much is given, much is expected. I really believe that you are one of the very few classes, one of the very few groups of kids who could have handled this with style and with grace. Nothing about this is easy. And please know that as teachers, this is not at all the way we wanted this year to wrap up either. I do hope that we can get through these assignments. Your yearbooks are coming, your diplomas are coming. There's a lot out there, guys, but just know that a lot of thinking and planning and praying and crying and an awful lot of debate has gone on to wrap up this year appropriately. And again, simple things like getting your textbooks back and all the supplies, etc. But I do hope that you have a chance to find a few moments in these last remaining weeks to realize what a blessed experience you had at Alcella. And guess what? You will be an alumnus or an alumna, if you're female, forever. And certainly it's been my honor and my pleasure to teach you this year. Have a great weekend, and we'll talk with you soon.